All right, so we're back, or did we ever leave? We talked about weird spaced out stuff. Check out the Midnight Gospel on Netflix; it'll blow your minds, folks. But in real world stuff, let's talk about correlation. So I kind of kept bringing the conversation heretofore back to this correlation question of sort
Yep.
of how we create these connections between entities. And so Nate's here, and we're going to talk about that correlation system.
Yes. Yeah. And I promised I would kind of give a little bit of kind of overall context. I want to talk about one specific capability that we released yesterday, which is around correlating via topology, or the relationships between the sources of alerts. But I drew up a couple of things. Let's see. So let's see. Just because in saying words versus kind of visualizing them
Yeah, when we say
will be
like, oh,
helpful.
topology-based correlation, it's like, some of us didn't go to a CS program at all, and we're certainly not in one right now. So like,
Yeah.
we're not ready to talk about network theory in words. Let's look at it in pictures.
Yes. So let's see. I'm going to flip between a couple of different visuals. The first thing I'll kind of set the stage with is what I think of as like the three major pillars or ways that you can correlate or group alerting events. So I call those alerting events like symptoms of the problem. Some piece of telemetry, you got high throughput here, response time or errors here. These are all coming out of a very connected, complex system. How do we group those together? So our approach is we think of as like an expert system. How do we create a system that allows you as the expert in it to encode your knowledge, your logic? So if you were to be given two alerts, you could determine how are these correlated? Should I group these together? Is this the same problem? And then the logic you're using can be encoded in the system to replicate that in the future. And previously, so I guess 2 days ago, our correlation engine worked off of two things. So let's see, we'll make topology, little dotted lines there. So we would correlate using time and frequency. So how close are the events together? So say you get two symptoms and they're 20 minutes apart. High chance they could be correlated.
Yeah.
If they're 6 hours apart, 2 days apart, less likely, right? The closer they happen in time, the more likely they are to have something to do with each other. So that's one input into the system. Then the second is what we call like contextual correlation. Like, okay, let's take a look closer at these alerting events. What type of metadata is on them? Do they have certain tag classes that help inform the fact that they come from the production environment? Probably don't want to correlate, a production alert and like a dev, or pre-production alert.
Yeah,
they have nothing to do with each other. So that context is super useful.
Yeah, that actually really points out something. I know we're going to get to this. Is like, very often we want to give ourselves more clues and say, hey, let's add a tag or let's add something to say, hey, these two might be related. But there's also the situation, where we have a tag or some other attribute where we say, because of this attribute, for sure not related, right? Anything that has a difference in its like environment, if it's like, dev, staging, production, do not correlate these two, right? They're certainly not going to be, one is not going to be have a causal relationship with the other.
Yeah.
Of course, you can come in and have everything be on fire all at once, but you don't want the two to be connected as if one is causing the other.
That's right. So generally, you kind of do a in context comparison, like, hey, they'll have the same environment value, and when they do, correlate them together, so you can have a very kind of flexible, piece of logic that just makes sure that the environment's always the same. That contextual comparison, we also do, some more advanced things. If you check out our docs, we talk about like similarity algorithms that can help do comparisons when you've got text or strings that are close but not quite. And you can do that on kind of individual pieces of metadata basis. And we also allow you to do it in what we call like the entire incident. So you can say like, if you've got alerts coming in from a system or multiple systems, and you just want to kind of like step back and blur your eyes, and you're like, oh yeah, this is like 80% the same as this other event, and I'm looking at the whole thing. You can do those type of similarity comparisons. And then when they reach a certain kind of percentage of being similar, then you can allow them to correlate together as well.
Yep, we talked about on a previous stream, and I'll probably link it in the description, right? We talked about the ability to say, hey, if this metadata is close enough, right? It's just, it differs only in capitalization or something, then go ahead and see that as contextually connected.
That's right. And it's funny, like you can do some very advanced implementations of that using these algorithms, and additionally use things like regex to solve some very specific problems. But it's funny just talking to customers. In some cases, like somebody just forgot to like capitalize something versus another, and they've asked that, hey, can you just like give me access to an operator that just can call these equal to each other? It would be so much harder to just go back and update the metadata from the
change
source.
All our logging calls and change all our message calls. Right? Yeah, I get it.
So you want it, and it's funny because you want you've heard like garbage in, garbage out. So, but and to some degree, like an AI app system just deals with a certain amount of garbage. So it's that balance of like, in some cases, I recommend customers go back and change your source system. The better the signal, the higher quality the output's going to be downstream and all these connected AI ops systems. But you can also leverage kind of the smartness of like a correlation engine to handle some amount of just like bad data, which is super convenient. Yeah. All right, so on to like the third leg, just to kind of round out this thought.
To round out the legs.
Round out the legs. You can't, the stool won't stand on its own, which is just the two. We got to have that third in there. And this is around relationships, right? So I want to be able to encode logic into the system so that things are, close in time, and there's a certain number of them in frequency. They have similar or require certain contextual metadata to be the same between them. And they must talk to each other. They must be in a graph of like, what we call like vertexes and edges. We'll talk a little bit more in a second, but just think of like entities that talk to other entities. If they work together, there's that needs to influence correlation. If you had a full environment graph or map, and you saw like two entities that have kind of met the previous criteria that I mentioned, but don't talk to each other, but are still in the production environment, you could correlate those together on accident. And so this kind of prevents that from happening and increases the quality of correlations, because you have now all these three pieces that really guarantee that these events absolutely are part of the same issue, and we want to group them together. So, okay, that's kind of the preamble, kind of setting you up, like, what is this topology thing? How does it fit into correlation? Since I have this up, this is what a graph looks like, and this is the one we're going to be using, and I'm going to be going for a full-on demo using our APIs and do this from scratch. So we'll see how that goes.
I love it.
I was inspired by Jules the other week. She was like writing code, and
Jules Sarah made us all look like fools. Jules Sarah was like, I am going to edit React, and I'm going to edit some query language live on screen.
Yes. So I'm hoping to get maybe 80% as good as that. I don't know if I'll be able to beat it, but
if it doesn't work, then it'll remind all the viewers, hey, sometimes it doesn't work the first time.
Yes.
Yeah.
All right. So this is kind of a contrived little graph we have here. We've got 3 services and 3 hosts, and if the lines are a little hard to see, it's like each host is serving all of these apps. So host 1 has an instance of app or service A, B, and C, and so forth. And then these services are connected to each other, where A calls B, B calls C. And so there's a kind of aligned or directed dependency there. And so this will be the basis. So just kind of think about this in your head as we kind of move through the demo here. All right. So what are the pieces to get topology-based correlation working? So the first thing we'll do is we'll just set up the decision in the UI. And this demo is so boring that I'm excited about it because it sounds like an advanced topic, but it's so easy to implement. It'll just take a few seconds here.
Yeah. So before we do it, though, I gotta ask, what is a decision?
Yes. So decisions are, let's see, I'm going to start. I got to delete this because I was doing a little test run before we got going here. So a decision.
Any decision, that makes sense. But what is a decision?
It's so another way to say it is it's a correlation decision. It's the logic that needs to be met in order for two alerts to group together. And so we do what's called like pairwise correlation. So let's see, I've got another, this is in our docs and this is live today. So I'll zoom in here just to kind of illustrate the point. So you can think of alerts kind of just flowing in time, right? And so we've got now and 20 minutes ago, and each of these like incident events are just kind of flowing through the system.
Zoom in and enhance by one step.
Yep.
We don't need to read these labels, and they're in the docs, and I'll drop the link right now. But just great. Now we're seeing what the picture is showing. So
yes. So you've got these incidents kind of flowing in time, and you can just think of our system as like we keep in memory and remember all of the alerts that have happened over the last couple of hours, and then we test them. So every combination of two alerts, we test against all of the correlation decisions that you've defined. So it's basically it's like emulating an SRE that looks at two alerts and then has a bunch of correlation decision logic, and then determines like, should these group together? Yes or no, and that's it. And so you're encoding into the system like the ability to say like, oh yeah, if they're 20 minutes apart and they have this contextual relationship and they're topologically connected, then yes, totally group them together.
Got it. So the big point here is that we're saying we're able to, I think, I gotta talk about these core paranoias for people with AI ops. Hey, if you don't want to use AI ops, I forgive you. It's okay. But if you do have concerns, here's one I think is sort of reasonable, is that you just kind of have to accept what comes out of the box, right? This is kind of the position that some people not in technical fields are, right? Where it's like, oh, well, the algorithm scored it at this, and you just don't know why, and you can't control what it's doing, right? And of course, that's not the situation here, right? Where a decision is one of those points where we can say, hey, right now you're generating these anomalies, you're generating these correlations, and we want to go in and say, hey, when this happens, I want you to do this exact algorithm. I don't want to trust your heuristic engine. I want to just go in and say, hey, I want exactly this to happen when the following occurs.
Yeah, that's right. And this comes from this, our correlation engine was born out of actual SREs that were on call for a system that generated a ton of alerts. And there's there's competitors in the market that do it different ways. These practitioners that built our correlation engine did it in a deterministic and dynamic way.
Yep.
Versus something indeterministic and hard to understand. So we want our correlations to be understandable, open, and repeatable, versus like somebody with like thumbed up and thumbed down something, and now like our correlation's all whacked out, and we don't know how to get it back to the way it was, and we don't understand when things correlate. Mm-hmm. It's too indeterministic, and for someone on call, that's no good. Like if you don't understand how things are grouping together, why they're grouping together, and when it might change, that can be super frustrating, especially if you're on the other end of a pager.
Yeah, it's 2 a.m. Yeah.
Get super helpful, like AI generated anomalies a dozen times, but the time that it generates something wakes you up and it's just completely, it's like, hey, staging and production both got delayed by the same amount at the same time. You're just like, oh boy, this was totally worthless, right? That will, if you cannot go in and edit the decision pattern, right, that will kill your trust in that system, right?
Yeah. And
you'll have people who do things like, oh yeah, just mute that channel for life, right? Never tell me about it again. And then we really won't be getting the benefit, right? That's the alert fatigue we all fear. So, okay. So great. Now I have some context on what is a decision.
Yep. Great. So we're on a journey here together to demonstrate what it looks like to build some logic. We'll create a graph, and then we're actually going to inject some alerts into the system and see if they correlate together based off of this topological dependency that we're going to tell the system exists. So fingers crossed, here we go. All right, first step, we're going to create a decision and get that logic into the system.
Can we zoom in a little bit?
We can. We'll see how well it responds to this amount of zoom. I think it's going to be okay, though.
I think this is good, yeah.
All right, so I'm going to do some pre-filtering. So in this first step, we call it filter your data. This kind of narrows down the of all the data incoming. This just sets up 2 buckets, because remember, it's like pairwise correlation. So I'm going to create a bucket 1 and a bucket 2. And in this case, it's going to be very simple. I'm just going to say, I'm going to create a bucket of incident events where there's an application name. The application name exists. And I'll do the same thing for what we call the second segment or bucket with the same exact rule. So we know that the only events that will kind of be considered have an application name. Then we'll skip step 2. But if you remember going back to our little diagram here, this is where contextual correlation is defined. So step 2 is kind of that pillar. We'll skip that for now, but that's where you can define that. We got great docs and you can check it out, how to use it. We're going to go to step 3, which is a new step. Once you have topology-based correlation lit up on your account, and it's going to be super simple. We're just going to say the relationship is going to be topologically dependent. That's the operator that we have right now. We're going to be adding more operators in the near future. We'll add that expression, and that's it. That's how you do it. You just say they're topologically dependent. We'll hit next. We'll name this thing. Let's say, what do we want to say? Topologically dependent, if I can spell. Okay. Correlated. Be
spelling while people are watching you.
I know, it's so funny. Yeah, I was like, should I put this in a clipboard? Like, no, I can just write it. Should have done that. Okay, before I hit create decision, just since we're here, you go into advanced settings. This is that other pillar, right? We've got time. You can adjust the time required for these events to have, be from each other in order to correlate. And then what we call the minimum activity to correlate, which means kind of the number of events within that time that are required in order to activate the correlation. So now we've kind of touched on all 3, like where are they in the UI? We've got, time and frequency, kind of context, and topology. So we kind of touched on all those. So on the right side here, you can just see very simple logic in place. We're going to only look at events that have application name, and then we're going to test to see if they're topologically dependent. So I'm going to create that. Cool. Next. So this first release we've built in a completely open platform way. So I was talking about that earlier. Like, I love that we're going open platform. So our approach here is that we're treating New Relic as a customer just of data and relationships, just as any other source. So our customers have relationships between entities defined in numerous places. New Relic does it for you automatically in many cases. You can also have what's called a CMDB, and ServiceNow kind of has like a big portion of that market. These CMDBs have like what are called CIs, or configuration inventory items, or something like that. They're like entities in there, and they have relationships. It's another product, and they have relationships stored there. We even talked to other customers that have relationships stored in a homebrew thing. They're like, oh, we got this Neo4j, instance.
They have an endless YAML that's like Borges Library of Babel, and it connects everything to everything else. They have it stored, right? They have it stored someplace, and they want to bring it in, and that's a very common, right, desire.
That's right, exactly. So we wanted to create a generic solution that can solve all of these problems. And so what we've done is created an API that can ingest topology. And so I'm in NerdGraph here. Basically gives you kind of a nice little graphical interface to, query and create things. And what I'm doing here is I did a query to see if there's any vertices or edges. There should be none because oops, page refresh. Let me try that again. I just cleared out this account, so there should be nothing in here. Wait for it to refresh. And what we're going to do is basically create that little graph that I showed you and define it from scratch in here. Let's see. There we go. It's back now. Great. So we've got nothing in there.
It's a live demo.
Live demo. We're doing it live. Okay.
Love it.
All right. So I did a little bit of cheating and I copied something in here. We're going to do a mutation. And a mutation is basically kind of like, your create, update, delete events called mutations in the graph. And you can see I've got something highlighted here that says AI topology collector create vertice. So we talked about vertices and edges. You can think of those as going back to our little diagram here. A vertice is, one of these little circles or squares. They're the entities, the nouns, the things you care about. And then the edges connect them together. So all the dotted lines are the edges. And so we're going to reproduce this in the graph here. So let's see here. I'm in this account, kind of highlight just a couple of things that get defined. So in this case, where's the name? Yes, so service A is the name of this vertice. It's an application. And then we have a couple of things that are called like defining attributes. Now this is important. This is like the most important part of how do you, customer asking questions. So how do you connect an alert coming in to something in this graph I'm defining? How do you know they have something to do with each other? How do you create that connection? And so this visual was kind of the most helpful way I could describe that in our docs, where you define a graph and each vertex can have just a collection of key value pairs. We call them defining attributes. They're the things that you'll likely find you need to find on the alert in order to create that connection. So you've got these alerts flowing in time. We basically look at all the attributes on those alerts and we say, hey, is there anything in this alert that we can find in the graph? Anything? So you generally want to use like unique identifiers, some sort of names, IDs, something unique. And we say, oh yeah, so see if I can zoom in a little bit more. So this CI ID is on the alert event, the incident event. It's flowing in. And we're like, oh, CI ID, I know that exists in the graph somewhere. And this service bar has that. So I'm going to connect those two together. So now I know that this alert came from this vertex or entity. And we do that for everything flowing in. We just kind of make sure we can map the two together. This vertex goes to this incident. And so why do we do that? So that we can test them. So if you've got, one, red incident, one yellow incident coming in, and we're like, oh yeah, we connected those to something in your graph. Well, once you have two, you can test them. You can test like, hey, are these topologically connected? Yes or no? And so that's all we're doing is we're saying, oh yeah, so these are 20 minutes apart, so they're close in time. Oh, and service foo, is dependent on service zip. They are topologically dependent. And so it does that test, super fast. And then if it passes, we correlate.
And so I know you mentioned that, sort of hopefully in the future, we'll see the ability to like even just go right in the New Relic UI and say, hey, these two things are dependent on each other or topologically connected. But it's pretty neat to see the API working in such a smooth way.
Yeah. So this is open for New Relic customers. One of our next things we're going to be working on is, New Relic, you like know those relationships between things already. So can't I just use those? I don't want to define it myself. Let's just use those.
Yeah.
So absolutely, that's the direction we're headed. And so here's the open platform. Now let's use the New Relic relationships, and that'll be kind of like an out of the box experience. That'll be pretty great. And if you got relationships elsewhere, totally works too. Bring them in and we'll work with those. All right. So I'm going to create the collection of vertexes here. So I've got, service A, B, and C, and host 1, 2, and 3, and they each have some defining attributes. So like if you find an incident flowing in and its application name is service A, then connect the two together.
So I really like this. Oh, I really, really like this.
So that was a success. Now I've got all the vertices created, but they're not connected together. So then we go and create the connections. I've got a little cheat sheet here, save some time. And so we've got all those vertices. Now let's connect them together. It's pretty easy. You can determine if
it's just like a two-dimensional array that says, hey, these are the ones that are connected. I'm sorry, go ahead.
You got it. No, you nailed it. So yeah, the edges is like, service A is connected to service B. And then there's just a quick Boolean here to determine if they're directed, which means like, is it a one-way, like this service A calls service B, or do they call each other? And so if they call each other, you say it's not directed, it's like bidirectional. But if you want to force these like arrows, so to speak, kind of going back to our illustration here, these are directed. So A calls B, B doesn't call A. So you can kind of force our operator to like follow the arrows.
Okay. Yeah. So this is kind of critical. Like if you say, hey, B is failing, but B never actually calls A. And so this will tell you something about whether or not you should see a correlation in that direction.
Yes, exactly. So all I'm doing here is basically saying, these, whether directed or not, and then which, vertex calls which vertex, and that's it. So I'll create that. Sweet, success. And then I've got a little query here that'll say like, show me the results of everything I just created. So this is just listing all the edges I've created. You see a list here, and then towards the bottom, cool. So I've got my vertices as well. So service A, B, and C, host 1, 2, 3. Great. So the last piece is we're going to create some alerts. I'm going to bring up, see if I can do 2 up here.
Yeah, so once again, while we can find anomalies automatically and see them in our activity feed, right? It of course takes some human effort to say, hey, I want you to actually ping me about this. And that's by design, right? We can create now, we can create as a source to say, hey, this connection of anomalies or patterns of anomalies should alert us automatically. But of course, most of the time we're going to want to, or often we're going to want to configure and say, hey, this is the time when I want an anomaly to wake me up with something that I didn't predict or didn't know was going to happen.
Yeah. All right, so we've got our feed here. This is where our kind of like raw incident events come in. You can see me testing previously. These are the incidents coming in via REST API versus coming in via New Relic alerts. So I've got, it's cool. So, memory issue just came in, so we got a little separator here. All right, so what I'm going to do is create incident A. Incident A has an application name of service A and then 937196. So that is one of the defining attributes that we defined in our graph. So let's create that. That was true. Let's see if we can get it to show up real quick. Great, there it is. Instantaneous.
Oh, I love it. I love it.
Okay, so now we're going to create incident B. So at this time, this is just kind of sitting here waiting to be correlated with something else. Service B is going to come in with another symptom, and we'll send that in. That's true. Great. And so let's reload that. Cool. So now I've got both in there. I'm going to zoom out just a little bit. So let's see if yes. So you can see new symptom, service A, another symptom, service B. Both of these came in. And if I go to issues, it won't be active because we're waiting for more correlations before we activate. It should be in a created state right now, kind of waiting for a few more pieces of metadata. And that's totally configurable, but you can see new symptom on service A, issue with 2 incidents inside of it. So it totally correlated. Let's make sure that it correlated using our new decision. And then that kind of rounds out the whole story. Let's see here. So great. So I see that, both of my incidents and the little lag between the two, you can see it kind of moving in time here, live, and great. So, and then at the bottom, we always want to tell you like why were things correlated so that it's super transparent.
For our last thing, even if
yeah. Here we go, and I can make it. I'll make it full screen. Cool.
Love it.
All right, scroll down. And then in the why was it correlated? Correlated because they are dependent, which was the description I put on there.
Yeah.
There we go.
Love that. Yeah, and I mean, this is such a thing, right? That very often when we have a UI that's telling us that there's a connection like this, a very critical piece is the human communication part of that says, hey, why did someone connect these two? Right?
That's right.
Like, yes, these two things never speak to each other, but they're both called by exactly the same front end element, right? Often for alternative, like whatever it is, right? Whatever that connection is, putting in a little note there will save you so much time. The most likely person, as we always say, to benefit from this little time you spend documenting these things is yourself. Is yourself unable to remember how or why or what it is that you did. Nate, that was so solid. I love that. I think we should wrap there. I think that looked good enough. We got to take a victory lap, right?
Absolutely. So yeah, that's it for topology-based correlation. If you want to get access to it, it's in limited release right now. So just ask your rep if this is something you want to get using. We'll get you lit up. We're going to be rolling it out in GA pretty soon, but it's here. It's ready.
Come talk
love to hear your feedback.
This is going to be something that's going to make a ton more sense, right? If you have a big complex stack, right, that you need to show these connections to. So, if you're instrumenting your first 3 things in New Relic, take a look at incident intelligence. It's going to be great. Anomaly detection. This is, as you get a little more advanced, talk to your rep and get this unlocked, and let's give it a try. But Nate, do you have stuff to plug? Is the SoundCloud album coming out?
Working on the SoundCloud album. Yeah, I'll let you know when the drop happens.
So the Nerd Blog comes back every Thursday. We post the last week's episodes about a week later. So they are available on YouTube. Maybe you're watching this on YouTube right now. We've had really good viewership on YouTube. So what the heck? Thanks a lot for checking this out. If you watch to the end, go find me on Twitter at serverlessmom and DM me the word spaghetti, and I will send you a hat. So thanks so much. For keeping on with it. Danny, do you have stuff you want to plug or mention?
Yeah, absolutely. Follow me on Twitter at Muy Danny, and I'm Muy Danny on Twitch. Stream every day. It's different projects. Hopefully, I want to order a 3D printer and print some homies. Do you guys remember homies?
Yes.
That you can get. Yeah, I want to print my own, so maybe that'll be happening in the future. But check out the Relic.
If you want to talk printers, I love the resin ones are getting so good now. That would be such a better way to make homies than with the additive printing. So yeah, we got to talk. Resin is really hot right now.
Cool. I'm gonna also DM you spaghetti so I can get a hat too.
Yeah. We're gonna raid in just a sec. I'm sure Danny, you can think of who we should be raiding, or Mia, if you want to do it in the channel. Do come back next Thursday for the Nerd Lock. Thank you so much for checking it out, everybody. Nate, thanks again for always knocking it out of the park. And we'll see you next week.
Later, everybody.